Okay, we are on 2015 FRQ number 6. All right, the last one here for this FRQ. Number 6 says, consider the curve given by the equation y cubed minus xy equals 2. It can be shown that the derivative is y over 3y squared minus x. So they did implicit differentiation there, right? So write the equation of the line tangent to the curve at the point negative 1, 1. So we talked about the word tangent, meaning that you have to find the derivative, but it's already done. It already found the derivative for you. So what does that do for you? Then this derivative allows us to find the slope. So in order to find an equation, I need the slope and I need a point. I have a point. So what is my slope? Slope is that that derivative there, y over 3y squared minus x, and my point is negative 1, 1. So plug in my point. 1 over 3 negative 1 squared minus, 1 over 3 1 squared minus negative 1. So that's 1 over 3 plus 1, 1 over 4. Right, so that's my slope. My slope is 1/4. So writing my equation now, I will get my tangent y minus y1 equals m times x minus x1. Okay, you can go ahead and leave your answer there because that is an equation. Some people really like slope-intercept form, so you can go ahead and continue if you want. So y minus 1 equals x over 4 plus 1 over 4. Add 1 over, y equals x over 4 plus 5 over 4. So again, this is a great answer. This is a great answer. It doesn't say which form. Either one's fine. Okay. Find the coordinate of all points on the curve on which a line tangent to the curve at that point is vertical. So you want a vertical tangent. When do we have a vertical tangent? When we're trying to divide by 0. Right? So a vertical tangent, right? Telling myself vertical tangent means that you are dividing by 0. And in other words, if it's a fraction, then that means the denominator must equal 0. It doesn't matter what's at the top, the bottom must equal to 0. So that means then my slope here, this denominator must equal to 0 to have this vertical tangent. So you have 3y squared minus x must equal to 0. So you get 3y squared equals x. Then what do? We go back to the original equation here. The original equation is going to be helpful because we can plug in the x. So the original equation says y cubed minus x y equals 2, and instead of x, I'm going to put in what I know here, which is 3y squared. Okay, so now I have y's I can go ahead and solve, right? You have y cubed minus 3y cubed equals 2. Negative 2y cubed equals 2. Divide by negative 2. Y cubed equals negative 1. Y must equal negative 1 because you can take the cube root of the y, right? And now plug it back in to solve for the x because you want to find the points, all the points that this is happening. So y equals negative 1, you get 3 times negative 1 squared equals x. So 3 equals x. So the point is 3. All right, for part C, you are looking for the second derivative on the curve where x equals negative 1 and y equals 1. So let's go to our derivative. dy over dx, or y prime, equals y over 3y squared minus x. So when you're taking the second derivative, don't forget you need to use implicit because there's y in here, and this is a quotient. So quotient rule and implicit, right? So y double prime equals low d high minus high d low. So low is 6y y prime minus 1 all over low squared, right? So don't forget, in implicit differentiation, especially when you're taking the second derivative, you want to plug in your y prime back into your equation so that you clean it up as much as you can on the right-hand side, okay? So you have 3y squared minus x times your y prime minus, I'm going to distribute this and go 6y squared times y prime plus negative y times negative 1, so plus y. All right, let's put our y prime in. Our y prime is y over 3y squared minus x, y over 3y squared minus x, and don't forget my denominator, 3y squared minus x squared. Okay, so good news is the first term cleans up beautifully. And then you have y minus 6y cubed over 3y squared minus x, and then plus y. And in the bottom, you have 3y squared minus x squared. Okay, so at this point, don't keep cleaning up, right? Because you know your values. You have x equals -1 and y equals 1. So x equals -1, y equals 1. Plug in those numbers, plug in those values. All right, y equals 1, so I have 1 minus 6 times 1 is 6 over 3 times 1 squared is 3. 3 minus a -1, all right, plus 1 all over 3 times 1 squared is 3 minus a -1 squared. Okay, so that's 1 minus 6 over 4 plus 1 all over 4 squared. So that gives me 2 minus 3 over 2 over 16, right? So 2 minus 3 over 2, that's 2 minus 1.5. So I have 1/2 over 16. When you have two denominators together like that, you can go ahead and multiply it together. So it's 1 over 32. And that would be the value of my second derivative at that point. Okay, that's it, guys.